All right, here are the teacher notes for the rolling ball on floor lab. Just to start off, we do have video of the wild guess question, but if you have a bowling ball and a ramp, you can do this at home or in your school, and it's a great thing to do in a hallway. Basically, the wild guess starts out with a bowling ball on this ramp, and we let it go. And we go ahead and just show students the ball rolling down the ramp, and then we ask them to make a prediction. How far after it hits the ground would that ball travel in 6 seconds? That starts out our question. Then students collect or work on an inquiry process where they collect data using a 1-inch ball bearing or a 1/2-inch ball bearing, or if you have a 2-inch ball bearing, you can use that too. But they're going to do collect data looking at, split them into 2 groups so that one group works on a high ramp and one set of groups works on a low ramp. We have this set up where the tall ramp is twice as high as the low ramp. So you want to be able to have, when students collect their results, some proportional reasoning. So if the ramp is twice as high, what happens to the motion of the ball? You notice that this heavy ramp we made for the bowling ball is really rigid and straight, while this PVC ramp right here, you can see that there's a sag in it. If you are doing the ball on ramp lab, is really important that this is straight. But so practice getting it straight, have students practice getting it straight during their ball on floor experiment, because they'll be better at it when they do the ball on the ramp. And just get a bunch of textbooks or different things that you can place underneath it and lift it up so that it is not sagging. Another thing you probably notice about this hallway is we have concrete floors. In the video of some of the data, you'll notice we did it in a gym. Actually had a bit of cushion on the floor. Some people have carpet in the hallways. If you want this experiment to work, the best way is you want to minimize any kind of friction. So a concrete surface is the ideal, or a hardwood gym floor. Once, what students are going to collect in this particular experiment is data of just the ball rolling on the flat ground. The whole purpose of the ramp is just so that the ball has a consistent speed at the bottom of the ramp, and then you're going to set up either in a hallway or a classroom with some space. You'll need about 3 meters for students to collect data. And what they're going to do is collect data on distance and time. Every 50 centimeters is a marker for distance. And then if they use a stopwatch, or you can use a video with a stopwatch in the video, they can find out how long it takes to go from a starting point of 0 to 50 centimeters to 1 meter to 1.5 meters, etc. Once they collect the data, they're going to go ahead and put their data into Desmos, and they'll find a graph that shows them the relationship between distance and time. And they'll find a mathematical model that shows, gives an equation for the relationship between distance and time. Once that happens, you put them into groups where some students who did the tall ramp work with students who did the shorter ramp, and through a data discussion, they actually uncover the relationships between the different graphs and what those differences mean in terms of the marbles and how they roll across the ground. And then once they have that data in the discussion, they will know that the slope of the line is actually the speed of the ball, and that the higher ramp has a higher speed than the lower ramp. And once they have that equation, or they have a graph, they can make a data-informed prediction on how far that would roll in 6 seconds. And then you go ahead and you test that again with the bowling ball, okay? One thing that's kind of interesting is students can then compare, how did the data compare for, say, a 1-inch ball bearing, the 1/2-inch ball bearing, or the bowling ball, and what they should determine out of all of that is that the mass of the ball does not actually matter about the motion from the ramps. Finally, we had collected data where we had a height of 44 centimeters for the tall ramp and a height of 22 centimeters for the short ramp. So when you see answer keys, those are based on the heights that we actually use to collect data. You may end up using different heights. The most important thing is that your low ramp and your high ramp, the low ramp is 1/2 of the height of the high ramp. Thank you.